Hey, welcome. Get ready, because today we're going to do something pretty awesome. We're going to write our very first lines of assembly code and literally speak directly to a computer's brain. So, yeah, let's get right into it. When you think about it, languages like Python or JavaScript are fantastic, but they're translations. Assembly is the real deal. It's the native tongue, the secret language that processors actually understand, and today, you're going to learn how to speak it. All right, so here's our game plan. First, we'll cover what this whole language of machines thing is all about. Then, we'll get to know our tool, Emu8086. After that, we'll learn the basic vocabulary, write our very first piece of code, and then we'll watch the magic happen in real time. Okay, so first things first. What exactly is this language of machines? Well, to put it simply, it's the most direct way a person can talk to a computer's central processing unit, the CPU. See, every single piece of software you use, your web browser, your favorite game, all of it, eventually gets broken down into these super fundamental instructions. So by learning assembly, you're learning to control the hardware at its most basic level. It's kind of like being a movie director who can tell each actor exactly what to do line by line. And hey, don't think this is just some old school skill. It's still absolutely vital today for things like optimizing game engines, programming the tiny computers in our cars, or even analyzing software for security flaws. Now, let's meet our main tool for today, Emu8086. What it is an emulator. It basically creates a little virtual microprocessor right there on your computer, giving us a totally safe and easy-to-use playground to experiment in. The real beauty of Emu8086 is that it's this all-in-one package. We don't have to go out and install a bunch of different tools. We can write our code, turn it into machine language, and run it to see what happens all in one single program. It's perfect. So when you open it up, you'll see this main window. For what we're doing today, we only need to worry about two parts, the big code editor over on the left and that register panel you see on the right. This area right here, the code editor, this is our command center. Think of it like a blank piece of paper where we're going to write down the specific orders we want to give to our virtual CPU. And then over here, this is the register panel. I want you to think of this as the CPU's brain just laid bare for us to see. Every single time our code runs an instruction, we're going to see the values in these little boxes change. It is literally our window right into the processor's mind. All right, before we can start writing our commands, we have to learn the two most fundamental words in the assembly language. These are registers and instructions. So first up, registers. Imagine you're doing a tough math problem. Instead of writing everything down on some huge whiteboard way across the room, you'd use a little notepad right in front of you for your quick calculations, right? Well, that's a register. It's a super fast, temporary little storage spot located right inside the CPU itself. It's the processor's personal scratch pad. Now check these out. These are the four main general-purpose registers we can play with. Each one has a special name and a primary job, like AX for arithmetic or CX for counting loops. But for our first program today, to keep it super simple, we're just going to focus on two of them, AX and BX. Okay, next up we have instructions. Now, if registers are the nouns, the places where we store things, then instructions are the verbs. They are the action words. They tell the CPU what to do with the data that's in those registers. And to get started, we only need to learn two simple commands. First is MOV, which just moves a value into a register. And the second is addED, which, you guessed it, adds a value to whatever's already in a register. See? Pretty simple, right? All right, now for the really exciting part. We know about registers, we know about instructions, so let's put them together and build our very first program. It is time to give the processor its orders. So our goal here is incredibly simple, just a little bit of basic math. Here's the plan. We're going to tell the CPU to move the number 5 into the AX register, then move the number 10 into the BX register, and for the finale, add the value from BX to whatever is in AX. So back in our code editor, this is literally what we type. First line, MOVAX5. This is us saying, hey, CPU, take the number 5 and stick it in your AX scratchpad. Easy. Next line, MOVBX10. Same idea. Now put 10 in the BX scratchpad. And finally, the grand finale, ADDAXBX. This tells the CPU, okay, take that number you have in BX, add it to the number that's in AX, and then store the final answer back in AX. That's it. Okay, with our 3 little lines of code all written, it is time for the payoff.
We're going to click that Emulate button and watch the direct result of the commands we just gave.
The second we hit Run, Emu8086 is going to read our first line, do what it says, and instantly update that register panel. Then it'll go to the second line, execute it, and update the panel again. We can actually watch our logic unfold step by step.
And here it is. This is the magic. On the left, you can see that before we ran our code, the AX register was totally empty. Its value was just 0. But after our code runs, look at the right. The value in AX is now 000F. Now, don't worry about the letter F. That's just hexadecimal, which is a shorthand number system computers use. The only thing you need to know is that F in hex is just the number 15 in our everyday decimal system.
And there you have it. It worked. It actually worked. Our program told the CPU to add 5 and 10, and the final result that it's stored in the AX register is exactly what we expected, 15.
And that's really it. Just take a second to let that sink in. You didn't just write some abstract code. You wrote a set of direct, explicit orders to a microprocessor, and it followed them perfectly. You are officially an assembly programmer. Congratulations. So now that you've had a taste of this power, now that you know how to command the very core of a computer, the only question left is, what are you going to command it to do next?